Assalamualaikum and hi everyone. Today we would like to present our project poster entitled Mini Hydro Power Plant, Sustainable Power System. Our idea is to create a small-scale hydro system that can generate electricity using rainwater collected at the rooftop. This system is simple, space-saving and can be a step towards green energy in buildings and communities. First, let me explain about the rooftop water tank. We choose to place the water tank at the rooftop, specifically block N, because the high elevation gives natural water head pressure. This means the water already has potential energy that can be used to drive the turbine. It is also very convenient for rainwater collection since the rooftop naturally channels rain into the tank. From here, the water can be distributed to the hydro system, and at the same time, it saves space because we don't need a river or dam, so it is practical for urban areas and buildings. Next, let's look at the important parameters of the system. The rainwater collection capacity, which we measure in liters or cubic meters. Tank height in meters to determine the water. Tank height in meters to determine the water pressure, flow rate in liters per second, and finally the power output, which is measured in watts or kilowatts. For the components, our system consists of a rainwater catchment from the rooftop, a storage tank to hold the water, pipes or penstock to channel the water, a mini turbine to convert water energy into mechanical energy, a generator to convert it into electricity, and finally an inverter and control system to manage the power and make it usable.
Now, let's move on to the block diagram. In a conventional hydro system, the process usually starts with a dam and a large reservoir. But in our mini hydro project, this is replaced by the rooftop water tank, which acts as a compact reservoir. From the tank, water flows down through the penstock pipe. Because of gravity and the height of the tank, the water gains pressure as it moves downward. This pressurized water is then directed towards the turbine. When the water hits the turbine blades, it causes the turbine to rotate. This mechanical motion is then connected to a generator, which converts the mechanical energy into electrical energy. Finally, the electricity can either be transmitted directly to supply the building or stored in a battery system for later use. So, this block diagram gives us a simplified but clear view of how the entire system works step by step, even though it is on a much smaller scale compared to the real hydroelectric plants. Our mini hydro project can bring several important impacts, both environmentally and socially. Firstly, it promotes sustainable use of rainwater for electricity generation. Instead of letting rainwater simply go into the drainage system, we are making use of it as a renewable energy sources. Secondly, it helps reduce reliance on grid power. If applied on a larger scale, this could lower electricity bills for buildings and reduce pressure on the national grid. Third, it can provide backup power during a blackout. Even though the system is small, it can still support essential loads like lighting or charging devices. Next, it supports the Green Building Initiative, which is very important for future developments. More and more buildings nowadays are moving towards self-sustainability, and our idea aligns with this trend. Another impact is that it is environmentally friendly. Unlike fossil fuels, this system uses renewable water without producing greenhouse gases. Lastly, our project can serve a pilot or demo system for education. Students, community, or even visitors can learn how renewable energy works through a real-life model. This helps increase awareness about clean energy and its benefits. In conclusion, our mini hydro project power plant system is sustainable and practically way to utilize rainwater for electricity generation. With the right design and proper setup, it can contribute to green energy, reduce reliance on non-renewable sources, and inspire the development of future renewable technologies. We believe that even though it is small scale, this project can show that clean energy is achievable anywhere, even in urban buildings. That's all. Thank you.